Section 3.3 is on the slope of a line. Slope is a measurement of the slant or steepness of a line. To read slope, we imagine traveling along the line from left to right. Lines that are increasing from left to right, such as the one below, have positive slopes. And lines that are decreasing have negative slopes, like the one shown below. Horizontal lines have zero slope, no rise, and vertical lines have no slope. So there's a difference between having zero slope and having no slope. It is possible to walk across a horizontal surface without lifting your feet 0 inches, but it's not possible to walk up a vertical wall. So vertical lines do not have slope and horizontal lines have slope of 0. The first method for finding slope is to compute the ratio of the rise to the run. Rise is the amount of vertical distance and run is the amount of horizontal distance. In example 1, a truck driver needs to choose which mountain pass to take. Pass A has a 20-foot climb for every horizontal feet horizontally. So the climb is our vertical distance. The 150 is our horizontal distance, that's our run. So since slope is equal to rise over run, for pass A, the slope is 20 over 150. Let's go ahead and reduce that fraction. If I divide them both by 10, I have 2/15. For pass B, there's a 15-foot climb for every 160 feet horizontally. So it's going to have a rise of 15 for a run of 160. If you divide those both by 5, you'll get 30 seconds. Now to be able to compare which of these is bigger, we're going to go ahead and make them both decimals. The decimal for the first one is 0.133, repeating. The decimal for the second one is 0.09375. So the larger value is the value in slope A. That's going to be the steeper path, which means that our truck driver is going to want to take pass B, the less steep path. In example 2, we want to graph the line that goes through the ordered pair 4, -2, and 7, 4. So let's graph 4, -2, and 7, 4. And we want to connect these with a line. Use your ruler to connect them with a straight line that goes through both ends of the graph and connects those two ordered pairs right through the corner of the boxes. Now we're going to find the slope using the rise over run property. To get from one point to the other, we can imagine a rise and a run forming this triangle right here. And the rise from one point to the other is 6 units if you count that. And the run, if you count from one to the other, is 3 units. So the slope is 6 over 3, or 2, since 6 divided by 3 is 2. The second method for finding slope, instead of counting the boxes between ordered pairs, we can subtract the y-coordinates and subtract the x-coordinates, then divide. So let's try that with these same two ordered pairs. If we subtract the y-coordinates, notice we're going to take y2 minus y1. It's going to be 4 minus -2, divided by 7 minus 4. The two negatives are going to make this an addition, so 4 plus 2 is 6, over 3 is 2. Notice that when we completed the subtraction, we have the same fraction 6 over 3 that we got by counting, and it reduces to the same value of 2. In example 4, we're going to go through both methods again. We're going to graph the points, and we're going to find the formula value of the slope. So if I graph -3, 4, it should be right here, and 3, -5. Let's connect them. And imagine the triangle that you get if you go straight down and straight over from one point to get to the next. This one goes down, if you count that, 9 units. Down 9 units is going to be -9 for the rise, and over 6 units if you count the distance between these two. So by this method, our slope is -9/6, or if I reduce that fraction, -3/2. Let's go ahead and use the formula and see what we get when we subtract the y values and the x values. Alright, so the formula said take y2, which is -5, and subtract y1, which is 4. Then take x2, which is 3, and subtract x1, which is -3. -5 minus 4 is -9, and 3 minus -3 is 6. I'll make addition right there. Notice it's the same answer we got when we counted, and if we reduce that, we'll get the same value of -3/2. In the next example, we're going to look at the slope of two parallel lines. Since these are already drawn for us and no ordered pairs are given, we're going to use the rise over run method to find the slope. So I first need to identify two ordered pairs. I'm going to start with the y-intercept, which looks like 0, 2, and then another ordered pair where it goes right through a corner seems to be this one right here at 3, 4. So I count the rise and the run. The rise and the run. The rise is 2 and the run is 3. So the slope of the first one is 2/3. Now let's find the slope of the next one. Let's look for an ordered pair. Looks like we have one right here at 0, -3, and another one right here at 3, -5. If I look at my rise and my rise is 2 and my run is 3. Now it didn't matter if I happened to choose these two ordered pairs, or let's say I chose two ordered pairs further up the graph. Doesn't matter what ordered pairs I choose, you can see that the rise is always the same and the run is always the same. So we always have the same ratio of rise to run no matter what 2 points on a line we choose. If you choose points further apart, you might get an unreduced fraction that will reduce to 2/3. The slope on both of these lines is 2/3. These lines are parallel, they have the same direction or same steepness, so they have the same slope. In the next example, we're going to look at some perpendicular lines. Perpendicular lines are lines that cross in a special way. They cross at a 90-degree angle. So let's find a couple of ordered pairs on the first line. The first line being the line that goes starting up here at the top and going down to the right. There's an ordered pair at 0, 5, and I see another one over here at -3, 9. So let's count rise and run. The rise is going to be down, so it's negative, and the run is to the right, so it's positive. So I have a rise of -4 and a run of 3. Now let's check out the next line. There seems to be an ordered pair at 0, -2 and another one at 4, 1. If you count the rise is 3 and the run is 4. What's the relationship here? So the relationship between parallel lines is that the fractions will be reciprocals and one will be positive and one will be negative. So perpendicular lines have negative reciprocal slopes. Let's use that information to fill in the chart below, for example 7. If the slope of a line is 5/8, the slope of a parallel line will also be 5/8. Parallel lines have the same slopes. And the slope of a perpendicular line will be, this is positive, so the perpendicular line is going to be negative 8/5, the reciprocal fraction. If my line has slope -5, the slope of a parallel line will also be -5. If I'm looking for a perpendicular line, since this is negative, my perpendicular line is going to have positive slope, and it will be the reciprocal of 5. 5 is 5/1, so its reciprocal is 1/5. If the slope is 0, the slope of a parallel line is also 0. The reciprocal of 0, since 0 could be 0/1, would be 1/0, but 1/0 is undefined. So we don't write 1/0, we write undefined. Another way of saying that is that this line has no slope. Now recall that a line that had slope of 0 was horizontal, And a line that had slope of no slope is vertical. And horizontal and vertical lines are perpendicular to each other. You can imagine a horizontal line going straight across, a vertical line going straight across in the other direction, and they do form a 90-degree angle. That's the end of our section on slope.